All right, we are going to look at intersections of secants and tangents. Now we've looked at intersections of chords and saw our formula. Now we're going to deal with intersections of secants and tangents and learn a couple other formulas. The first thing they want to know is a warm-up, reminding ourselves what two vocabulary words involve lines that extend outside of the circle. Okay, number one, we're looking at lines. Okay, so here we got lines, and we're going outside the circle. And as a reminder, it's also in the title. We've got our secants and tangents. So we want to identify each of them. So the first one we're going to identify is going to be our secant. Okay, the secant slices. Okay, secant slices. So it's going to be the line that goes into the triangle, into the circle, slices through, and exits out another end. So we take a look at the lines. Here we have line MN slices through. Okay, it's going to be a line that continues both directions forever. So we're going to put that line symbol over the letters MN. Our tangent, the word that I always say, hey, what to remember is your tangent touches. So your tangent is going to be another line, but it's barely going to touch that circle. It's just going to brush by that circle. And here we have line NP, making sure we have our line symbol above it. Again, please make sure that you are pausing when needed. Your tangent intersections. What happens when two tangents intersect? So tangent first is going to be defined as a line, as we just talked about, that touches the circle, the line that touches the circle at only one point. Sorry, the line's kind of not long enough there. So it's going to be a line that touches, just barely touches. Now we have two tangents that intersect outside of a circle. This is what it's going to look like. So we have two tangents intersecting. They're always going to intersect outside the circle. Now we talked about tangents are lines. These are actually segments, but we have to have segments so we can have measurements on this one. Okay, if they kept going, we'd have lines like this, and these two would intersect right here. What is happening with these two tangents is they are intersecting at point H. We just cut them off to make them segments. We didn't keep them going forever and ever. So we're going to name the two tangents in this diagram, and we've got tangent. We'll go ahead and put, they are going to be segments on this one, so we're going to put segment JH right here and segment FH. The two tangents intersect, their lengths are going to be equal. So lengths are equal. So all it's going to be is basically just your tangent is equal to the tangent, the other tangent. We're going to put tangent 1 is equal to, remember where I'm at spelling, tangent 2. So in this diagram up here, we would just say that JH is equal to FH, the lengths, and that's why we have these congruent marks right here. Okay, so we just set them equal to each other. So if you use something that looks like this, kind of like an ice cream cone, okay, we're just going to set them equal to each other. So this one right here, first we're going to find, we've got this tangent-tangent intersection. We're going to solve for x, and then we're going to solve for JK. So we're going to go ahead and substitute in. So here we remember that these are congruent, so we're just going to set them up equal to each other. JK will be equal to HK. So let's go ahead and plug these in. JK is 2x plus 5. We're going to set that equal to HK, 3x minus 2. This is where I ask you to please take a moment, pause this video. Okay, I'm making these videos shorter by having you work this out on your own. You need to be able to solve for x, so you should have paused this video and worked it out on your own. So here we go, about to have your answer. Hopefully you did what you're supposed to do. We're responsible about it, and we're going to have x is 7. So now with that being said, we're going to go ahead and we wanted to substitute in also for JK. So JK is going to be right here. So to find JK, right over here, JK, it was 2x plus 5. So we're going to substitute in for x. That's 7 in there. These colors very close together. Plus 5, and then we just solve it through. 14 plus 5. The length of JK is just going to give us that 19. Okay? So now let's talk about if we have a tangent and a secant that intersect each other, okay? We're going to remember that a secant is defined as a line, so we're going to have another line. It's going to be a line that touches the circle at 2 points, okay? A line that touches the circle at 2 points. So the chord has two, it's a segment, and the line, or the secant is going to be the line. Remember, this is going to be one that's going to slice through. So here we're going to name the tangent and secant. First, we want the tangent. The tangent, remember, is only going to touch at 1 point. So we're looking at here at segment UV. Okay, it only touches it at that 1 point. Your secant, on the other hand, is going to slice through. So it's going to hit this circle at 2 points, at point X and point Y. So the name of this secant, we have to start with U. We cannot start with X. XY would be a chord because it never leaves the circle. Your secant slices into that circle. So we have secant segment UY. So we have a formula with this that involves our tangent and our secant. So when you have a tangent and a secant, the formula is simply going to be, you're going to take, and we'll make this a little bit more clear here in a minute, you're going to take the outside part of the secant, and you're going to multiply it by the entire whole length of the secant. This is going to be equal to your tangent squared. So let's break this down. Pause and get that written down so I'm not moving on without you paying attention. So what you're going to want to do is maybe just kind of look at what I'm going to do and trace with my colors, and then press pause and then get that filled in so you can actually visually see when you're not looking down at your notes while you are I'm explaining. Okay? So we're going to use this formula. We're going to have our outside. So the outside and the whole go with the secant, the one that slices through. So the outside is going to be just this portion right here. Okay, this is your outside. So we're going to take that 9 times the whole part of the secant. So this whole entire thing. So what you're going to have to do is add these together, and this will be x plus 9. Okay? So we add those together to get the whole entire thing of x plus 9. This is equal to our tangent squared. Your tangent never goes inside the circle. It's the one outside. So here we would have 15 squared. What I want you to do is try to solve this. Now again, you should be pausing and getting it all written down with your colors. I'm going to encourage you to try to solve this on your own, but if you do need me to walk through with you, let's go ahead and work on this, okay? I see a whole number over here, okay, and I see something being added to x, so I know I'm going to have to distribute. That 9 times the x is going to give me 9x. I'm going to distribute that 9 times the positive 9, giving me a positive or plus 81. On the other side, I have 15 squared. 15 squared, we should have our squares memorized, is 225. Now the rest of this you should be able to do on your own. Okay, so I'm going through it very quickly. I'm just going to subtract the 81 rather than worrying about pausing it. We have 9x going to be equal to 144. Divide both sides by 9. X is going to come out to 16. Okay. Now, we talked about when two tangents intersect. We talked about when a tangent and a secant intersect. What happens if two secants intersect? Two secants intersect outside the circle. It's going to look like this diagram over here. Okay, so we have two secants. Again, like tangents, they're going to intersect outside, but notice how both of them are slicing into that circle. Slicing secant. We're slicing, going from the outside, slicing into the circle, secant. When we have these two secants that intersect, our formula is going to be the same thing on the left and the right of our equal sign, but we're going to be dealing with the two different secants. So we're going to be doing this outside versus total again, or whole. I think I wrote whole on this other one. the formula we're going to give you is going to be, sorry about this, is going to be total. So if you want, I mean, if you like the word whole, that's fine, but the formula chart you're going to have is going to say total. Pause and make that correction real quick. All right, so our formula here is going to be on one secant, like with the chords, we dealt with one chord on one side of the equal sign, one chord on the other. So we're going to go to one secant, and we're going to do the outside of that secant times the total of that secant. And we're going to set that equal to the other secant's outside times total. And I told my students you're going to have to know these different words, because when I say secant, you need to understand which line or segment I am talking about. All right, so we're going to go ahead and look at what we have here. We're going to use this information in this formula. Let's take a look at one secant here. We're going to have the outside, which is just going to be the 3 right here. Okay, so we'll take 3 times the total, okay, the whole secant, which we have to add that 3 and that 5 together to get 8. And I kind of wrote over 3 over here. And then we're going to set it equal to the other secant's outside, which is going to be the 4, times the other secant's total, and that x is inside, okay? Again, like we did on the tangent secant one, we need the total. We need to add these together as an x plus 4. I'm going to encourage you to pause and work through this. We know we have distribution over here. Over here, we're just multiplying the two numbers together. So please pause it now and go ahead and work through it. Okay? What I'm going to do now is just go ahead and throw this stuff down here. We're going to have 24 on one side. The right, we're going to distribute that 4 to the x, giving us 4x. And we're distributing that 4 to the positive 4, giving me plus 16. At this point, take the last 2 steps. If you needed me to help you through that first part, that's fine. Pause it now, please. I'm going to do the answer's about to pop up, so please pause it. Quick, quick, quick. And here is what x should have been equal to. And check your work with mine. And we have gotten to discuss 3 different intersections here, 2 tangents, tangent secant, and 2 secants.